Even in a competition between giants, there's always going to be a party that loses out. Such is the story of Northrop Corporation's YF-23 aircraft, of which only 2 prototypes were made, lovingly known as the Black Widow II and Grey Ghost. Today, most people have forgotten about this phenomenal aircraft, and even those who remember it have placed it as a footnote of history, as the aircraft that lost out to the mighty Lockheed Martin's YF-22, now known as the F-22 Raptor. But the aircraft that Northrop Corporation produced was anything but unforgettable. Today, we will dig up the past and tell you why the YF-23 was a masterpiece of modern engineering. "40 years ago, the chances of a nuclear war was quite possible. With 2 superpowers involved in an invisible war, it was felt that the United States would find themselves in a terrible shooting war against an extremely heavily armed Soviet Union. With a 4-to-1 military advantage belonging to Soviet forces in Eastern Europe, those were legitimate concerns not only for the United States, but also their political allies in Europe. At the time, the United States and its allies were heavily dependent on the F-15 Eagle aircraft. Although a brilliant aircraft in many regards, it was getting old and had a very slim advantage against the new Soviet aircrafts like the MiG-29s and the highly modernized aircrafts in the Su-27 family. It was enough for the United States Air Force to realize the need for a new fighter. Thus, it took a bold step in the early 1980s to come up with the new requirements of a new air superiority fighter under a program called the Advanced Tactical Fighter, or ATF program. From the initial requirement stages, the main focus of the US Air Force was on a few features that the new aircraft would absolutely need to have. It included all-aspect stealth, meaning the ability to have a reduced radar cross-section over various flight regimes. The engine should be able to supercruise, which is flying at supersonic speeds without the use of an afterburner. The use of composite materials and new alloys in construction processes to reduce the overall weight of the aircraft, advanced fly-by-wire systems to make the aircraft more maneuverable, and finally, the aircraft should have short takeoff and landing, or STOL, capabilities. After the initial years of evaluating proposals and designs, the prototyping and flight testing contract was awarded to Lockheed Martin's YF-22 design and Northrop Corporation's YF-23 design in 1986. Northrop Corporation has always had a history of building high-performance aircrafts. Its founder, Jack Northrop, was the first aviation designer to pioneer the flying wing concept, which led to the eventual development of the B-2 stealth bomber, which is currently the primary long-range stealth bomber of the United States Air Force. Following the same legacy, the designers at Northrop partnered with McDonnell Douglas to design the YF-23, which many still consider to be the most technologically advanced aircraft than its competitor. The YF-23 prototypes were 67 feet 5 inches in length and had a wingspan of 43 feet 7 inches, which was slightly bigger than its competitor, the YF-22, giving the YF-23 a slight advantage in range and speed. The prototype air vehicles, PAV-1 and PAV-2, were powered by 2 Pratt & Whitney YF-119 and 2 General Electric YF-120 afterburning turbofan engines respectively. Both engine types were able to meet the minimum ATF program requirements of generating 35,000 pounds of thrust with afterburner, with the ability to supercruise. However, in the end, the Pratt & Whitney YF-119 was chosen to power the winning entry of Lockheed's YF-22. Both prototypes could reach a maximum speed of Mach 2.2 and supercruise at Mach 1.6. Northrop's prototype was the first to take to the skies. PAV-1 took its first 50-minute maiden flight on the 27th of August with Alfred Paul Metz at the controls. PAV-2 took flight shortly after on the 26th of October and was piloted by Jim Sandberg. By all accounts, the design of the YF-23 was brilliant, with some very advanced design elements. The aircraft was configured with diamond-shaped wings, or trapezoidal wings, which allowed the designers to reduce aerodynamic drag at transonic speeds between Mach 0.75 and Mach 1.2. This meant that the aircraft had good low-speed performance, despite being an overall fast jet. The trapezoidal wing setup also offered advantages for high-speed flight as well. A small and highly loaded wing, such as the YF-23s, offered substantially lower drag at supersonic speeds than other configurations. The wing's tapered layout also reduced structural stresses, allowing the wing to be made thin, thus using less material during construction and keeping the overall weight of the aircraft low. Along with the unusually shaped wing, the YF-23 also featured an all-moving V-tail in favor of the more traditional vertical fins and horizontal surfaces. This kind of tail design is sometimes called a butterfly tail, which is an unconventional design but offers some direct advantages. This configuration reduces the overall exposed surface area of the tail, which not only leads to less parasitic drag, but also makes the rudder controls more effective, allowing the pilot of the YF-23 to achieve more airspeed and maintain proper yaw controls during high-speed flight. Moving forward, the cockpit of the YF-23 was placed very near to the nose of the aircraft to improve overall pilot visibility. The aircraft had a conventional tricycle undercarriage layout, with the internal weapons bay placed on the underside of the fuselage between the nose and the main landing gears. This meant that the aircraft would carry all its weapons inside and not on wing hardpoints. This choice was made to maintain all aspects stealth of the aircraft, as weapons on external hardpoints are the primary factor in increasing an aircraft's radar cross-section. The two engine manufacturers powering YF-23's PAV-1 and 2 were in their own competition to see which one could produce the best-in-class supercruise-capable engine. Combined, both engines on YF-23 produced approximately 70,000 pounds of thrust, which is equivalent to more than 40,000 horsepower. In comparison, an average Arleigh Burke-class destroyer has a total of 100,000 shaft horsepower. This new generation of engines almost doubled the thrust available to the YF-23 from its nearest counterpart in the US Air Force Service, the F-15 Eagle, whose two Pratt & Whitney F-100 engines could only produce around 40,000 pounds of thrust in the afterburner setting. This increase in engine performance was a big technological breakthrough for the ATF program, as it led to the creation of the first supercruising jet fighters in the world. It meant that fighter jets would no longer have to rely on gas-guzzling afterburners to reach supersonic speeds, saving valuable fuel and increasing the overall range of the aircrafts. A major challenge for ATP program designers was to provide stable airflow to high-performance engines on an airframe that's hard to spot on radar. Simply put, the issue had to do with boundary layer air that spreads around the aircraft's fuselage as it flies. Boundary layer air can flow at different velocities and directions compared to the air that's offset from the aircraft's surface. Mixing these two streams of air can lead to large drops in engine efficiency. During certain regimes of flight, boundary layer air can become highly turbulent, largely impacting the engine's performance or even suffocating it. At supersonic speeds, these issues are compounded even more. The YF-23 featured a trapezoidal engine inlet with S-ducts, and some very clever solutions to make this program go away. Prior to the ATF program, supersonic jets dealt with this problem using elaborate splitter plates to separate the two airflow and maintain uniform supply through the inlet opening. But those concepts were not very conducive to stealth. Even a small gap between the inlet and the fuselage can result in a radar cross-section increase. Thus, the designers of the YF-23 came up with an innovative solution. They installed gaussing panels ahead of where the fuselage meets the leading edge of the air inlets. These panels had small holes drilled all over them and would suck up the boundary layer air, sticking to the fuselage before it entered the air inlet. This air was then vented out through a pair of small doors on the YF-23's upper surface. In effect, it acted like an invisible splitter plate of sorts, but instead of separating the air, it removed it. The system was called the Boundary Layer Control System and worked automatically. This configuration of the inlet, coupled with the gaussing panels, feed the massive engine compressors with a steady stream of air, even at supersonic speeds, while maintaining all aspects stealth. Unlike its competitor, the YF-23 did not feature a thrust-vectoring engine nozzle. Some say this was a massive disadvantage for the YF-23 in the ATF program and reduced its overall maneuverability, making the aircraft less agile in low-speed regime. However, According to the designers of the aircraft, they sacrificed a little bit of agility to gain a lot more survivability. Due to the flat nature of the YF-23's fixed engine nozzles, the designers were able to line them with heat-ablating tiles, thus reducing the infrared signature or IR signature of the aircraft to heat-seeking surface-to-air and air-to-air missiles, the main weapon system that an enemy will deploy against a low observable stealth air superiority fighter. Just like the company's B-2 bomber, the heat-ablating tiles significantly dissipated the engine nozzle temperature, which was anywhere between 3,000 and 4,000 degrees Fahrenheit. On the other hand, in order to be maneuverable and maintain its agility during air-to-air combat, the YF-23 prototypes were installed with multiple aerodynamic instabilities, which were all controlled by its advanced fly-by-wire system. The YF-23's core processor was considered as the most advanced supercomputer of its era, performing nearly 5 to 6 billion operations per second. The system not only managed the flight controls of the aircraft, but also provided radar, navigation, performance data, and situational awareness to the pilot, all in real time. All these features made the YF-23 a real technological marvel of its era. The armament system of the YF-23 prototypes were based mostly around air-to-air missiles and air-to-ground bombs. Since all missiles and bombs had to be carried inside the internal weapons bay to main stealth, the overall payload capacity was not that great compared to other conventional fighters. Despite this, all the necessary weapons needed in an air superiority fighter were available to the YF-23's pilot. The aircraft could carry the standard AIM-9 Sidewinder for close air-to-air fire, and also the AIM-120 AMRAAM or the AIM-7 Sparrow for medium to beyond visual range targets. The aircraft also featured a main M61 Vulcan cannon, which could fire 20mm rounds at a very high rate of fire of around 6,000 rounds per minute. Finally, given the mission types, it also had the capability to carry up to 2 1,000-pound or 4 500-pound air-to-ground bombs. All in all, the two YF-23 prototypes tested well and checked all the boxes required for the ATF program, and some argue even beat its competitor, the YF-22, in areas of speed, range, and overall performance. However, today we all know how the story goes. After 4 grueling years of testing and evaluations, YF-22 was selected as the winner over the YF-23. The designers of the two YF-23 prototypes have always remained firm on their belief that their aircraft was superior and more technologically advanced of the two. However, various political forces and lobbying swayed the decision in favor of Lockheed's YF-22, which is still currently in service as the F-22 Raptor. A total of 195 F-22 Raptors were produced, and the production finally stopped in 2011. On the other hand, the two YF-23 prototypes, PAV-1 and PAV-2, were donated to air museums, never to be flown again. But in recent years, there's been a glimmer of hope for the revival of the YF-23 in the form of Japan's F-3 sixth-generation fighter. Japan is seeking the help of Northrop Grumman in aiding their design and development of its F-3 fighter program. And given the entire experience gained during the development of the YF-23, the company is optimistic in securing the contract for this project. Regardless of what is in store for the future, as aviation enthusiasts, we'd love to see the return of the YF-23 in its reincarnated form, taking to the skies and finally bearing fruit to all the research and hard work that was spent in making this magnificent aircraft that everyone seems to have forgotten. So what do you think about the possible return of the YF-23? Let us know in the comments section below. And keep up to date on advanced military weapons and news. Click the subscribe button and turn on notifications, and we'll let you know when a new video arrives. Thanks for watching.